Alright, this is going to be a short lesson on section 5.6, which is long division of polynomials. A lot of people have trouble with this. So since you can't have any face-to-face instruction, I thought I would tape a small little tutorial, and then hopefully this will help make things a little bit more clear than reading the words on my math lab. All right, so first let's just think about like regular division. For example, let's just do a problem like this. You know when you start this that you're taking the guy out front, your divisor, and you're trying to figure out how much it can go into your dividend, the guy inside. So we go to the first part that it can go into. You multiply, or you figure out how many times it goes in there, and you put that at the top. Then you take what you got and you multiply it by the guys outside. Then you subtract, and then you bring down. So we multiplied first. Well, I should say we divided first. We multiplied second. We subtracted third. And we brought down fourth. Now, once we bring down, then we don't even look at this number here anymore. We're going to always be looking at what's down here, what we've subtracted, our difference. And then we're going 26 into 138. And we'll say it's about 5 times. And then we start this whole thing over again. We figured out how many times it went in there. We multiplied our 5 times our 26. We subtract, and we bring down. We start over. How many times is 26 going to 83? 3 times. 78. Subtract. And then bring. We don't have anything else to bring down, so this is our leftover. Now we would say 153 and 5 26s, or we could keep going and use a decimal, but for the purpose of this section, we're going to kind of do it in a fraction way. So these 4 steps that we used for this long division problem are the same exact steps that we're going to use when we do a polynomial. It looks different, but honestly it follows the same concepts. So if you can remember those 4 rules, you should be successful. So let's just start with, and I'm taking these out of the book. If you follow the book, this is chapter 5, page 392. Remember, you have access to the book through my math lab, so if you want to follow along, that's where these problems come from. Alright, so there's our problem. And then we're going to keep our 4 steps in mind. Alright, so we're not trying to do this whole thing into this whole thing. We're going to take it off in little bits and pieces. So really you're just starting with your x into your x squared. So if you remember our division rules, this should have been the section right before this. X goes into x squared, x times, because you subtract your exponents, and this would be a 1, so it would be x to the 1 power. Doesn't matter where you put it on at the top. Alright, and that was our divide section, our step. Then our second step when we did a long division here was we multiplied. So we're going to do the same thing here. We're going to multiply our x here by the whole thing on the outside. So we're doing x times x plus 3. So that's our distributive property. So we're going to do x squared plus 3x. Our third step when we did the regular long division was subtract, so that's what we're going to do here. Now when you subtract a polynomial, it's like parentheses are around this whole thing and we're subtracting the whole thing. So if you remember, just to subtract means to change the signs of everything, then you'll do this correctly. So this was positive, now it's negative. This is positive, now it's negative. So you're changing the signs of everything. If this was a negative, it would have changed to a positive. So now we can subtract. If we did this correctly, this should equal 0. If it doesn't, then something's wrong. Alright, and we can subtract here. 10x take away 3x is 7x. And then just like our fourth step, we're going to bring down the next section. Then you're going to start those 4 steps over again. X into 7x. Well, those cancel out and they leave just a 7. If this is positive, we'll put a plus here. If this is negative, we'd put a negative here. So we found it 7 times. 7 times x is 7x. 7 times 3 is 21. Subtract, which is changing the signs of both. This should cancel out if we did it correctly. It did. And in this case, we end up with no remainder. So our answer is x plus 7. And let's do one more similar to that. We have x squared plus 14x plus 45 divided by x plus 9. Alright, so we're just starting at the beginning with our x and our x squared. And you don't have to write this down every single time, but hopefully it helps you see where I'm getting my answers. So this is x, then x times x plus 9, so everything on the outside times what you just found. X times x is x squared, x times 9 is 9x. Subtract, which is change the signs of both. Canceled out perfectly, left with 5x, bring down. X goes into 5x 5 times. 5 times x is 5x. 5 times 9 is 45. Subtract is changing the signs of both, and this time we also have 0 as our remainder. So our quotient is x plus 5. So those are pretty straightforward ones. They come out pretty. You won't always see those. Maybe just for practice, that's about it, but you know, they like to throw the harder ones in there. Alrighty. The book kind of gives one that's all crazy. So remember, this is a division problem. That's what this means. The bottom always goes outside. Now, before we start, you should always write this from highest exponent to lowest. So and make sure when you rearrange that the correct signs are coming with it. Whatever's in the front of it is the sign that comes with it. Alright, so now we're starting with our 2x going into 4x cubed. So that's what we're doing. This is squared. So remember, subtract and then take care of our coefficients. 2x times 2x minus 1. So that's 4. Oop, 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 oop. I made this a 2. This is a 1. So this is actually a squared here. Hopefully you caught that. I noticed it when I went to multiply, it didn't work out. And that's how a good sign that, you know, pay attention, because when I multiplied those, that came out to x squared, which is not the same thing as x cubed. You cannot subtract two exponents that aren't the same. So that was my cue that something wasn't wrong, and I went right, and I went back and saw what was wrong. Alright, so 2x squared times 2x is 4x cubed. 2x squared times negative 1 is negative 2x squared. Now when you do these should always be lining up. X squares, x threes, when we do the x's, they should all be the same. Subtract, which is changing the signs of both. Cancels out perfectly. Left with 2x squared. Bring down. And we're starting over. So this is 1, so we're left with 1x, and negative 2 divided by 2 is negative 1. So I'm just going to put an x up there, negative x. Negative x times 2x is negative 2x squared. Negative x times negative 1 is positive 1x. Change the signs of both. Gone. Left with 6x. Bring down. 2x goes into 6x. Positive 3 times. Remember, if this is positive, this will be positive. Just as this was negative, I put a negative. 3 times 2x is 6x. 3 times negative 1 is negative 3. Subtract, which has changed the signs of both. And I'm left with a remainder. Now when you're left with a remainder, remember it is just taking, excuse me just a second, your remainder and putting it over what was on the outside, our divisor. Now you need a sign, and we always just put a plus in here. Oops, I'm sorry. So this was a negative 6, and our divisor was 2x minus 1, and then we just put a plus. So it is, the whole thing here is your final answer. I just wrote that in the wrong place. You guys think I'm just nuts, don't you? That was our original problem. No, don't look at that. Alright, so here's our final answer. Life's too short. Don't take yourself so serious. Laugh at your mistakes. Alright, let's do one more like that. Let's see. We have 6x plus 8x squared minus 12 divided by 2x plus 3. So this is our problem here. When I set it up, we have this guy on the outside, and then we want it in descending order. Highest exponent to lowest, and constants are last. Alright, so we're doing 2x goes into 8x squared, so that's 4x. And you can multiply it real quick just to make sure that you have it correct. Our next step is to multiply what we have here times both of these, so 4x times 2x is 8x squared. 4x times 3 is positive 12x. Subtract, which is changing the signs of both. Comes out perfectly 0. Negative 6x, bring down. 2x going into negative 6x, so that's negative 3 times. 3 times 2x is 6x, negative 6x. Negative 3 times positive 3 is a negative 9. Change the signs of both, and I'm left with a negative 3. I've brought everything down, so that is our remainder. And here's our final answer. Alright, so sometimes they come out pretty, you have no remainders. Sometimes you have remainders and they write them in a weird order, and you just got to make sure you arrange them. And then the last thing that you're going to see is problems like this. Alright, so when I set this up, I need to have an exponent in every group all the way down to the constant, which means I need an x squared. I need an x. We can't have a gap between here and here that doesn't include those exponents, because when we do our synthetic or our long division, we're going to have some missing terms that don't match up. So what you do is you have a placeholder, and we're not changing the problem. 0x squared is still 0. It's just a placeholder. And then I also need an x, because we want it to go down in descending order before we get to our constant. So sometimes you might have an x cubed and then an x, so you just got to make sure that you include the placeholder for the x squared. The same thing can go for the divisor. If the bottom of this one was 2x squared minus 1, then we would have to write our divisor 2x squared plus 0x minus 1. So they both have to have descending. The only thing that goes next to our constant is our x to the first power. Alright, so then we'll just start like we always have. 2x going into 8x cubed is 4x squared. 4x squared times 2x is 8x cubed. 4x squared minus 1 is, times negative 1 is negative 4x squared minus, change the signs of both. So see, if I wouldn't have had the placeholder here, I would have had a 1 here. Well, 1 and x squared do not match up, so you can't add and subtract unlike terms. So that's why it was important to have our placeholder. Alright, when I do 0 plus 4, I get 4x squared, and then I start again. 2x goes into 4x, 2x times 2x is 4x squared. Oh, I forgot to bring down my next. 2x times negative 1 is negative 2x. Change the signs of both. So like before, if we hadn't put the placeholder in here, then we would have had an x with our 1, and we can't combine unlike terms. I change the signs of both, and we have 2x, and bring down. And then we have 2x into 2x, so this is a positive 1. 1 times 2x is 2x, 1 times negative 1 is negative 1. Change the signs of both, so this one came out nice and pretty. Let's see. So let me do one more, and hopefully that is enough to get you started. These usually are everybody's least favorite ones, but honestly I really like them. I think they make you look at a division in a whole different way. Alright, let's do x 4 minus x3 minus 7x squared minus 7x minus 2 divided by x minus 1. So I just made this up, so this is kind of scary how this might turn out. But the good thing is, even if I make it up, we still should be good. We'll find out. Alright, so x goes into x4, x 3 times. x3 times x is x4. Oh, and I forgot to mention too, these go down in descending order, so that's something you should always pay attention in, because you're going to mess yourself up if you don't. Alright, negative x cubed times, or x cubed times negative 1 is negative x cubed. Subtract, change the sign of both. Gone, gone. So we have nothing left. And this does happen too. So then you're just going to bring down the next number. Now you have to bring down the next two numbers, because you need two things. You know, we always had two things here. But we're still just doing x into negative 7x squared. So that's negative 7x. Negative 7x times x is negative 7x squared. Negative 7x times negative 1 is positive 7x. Subtract, we'll just change the signs of both. And this should have been a positive. So it turned to negative. Oh, I think I did that. Okay. And that's negative 14x. Bring down our next one. Negative, or x into negative 14x is negative 14 times. Negative 14 times x is negative 14x. Negative 14 times negative 1 is positive 14. Subtract, let's change the signs of both. And we have brought everything down, so this is our remainder. And it just gets placed over our divisor. So that's as crazy as you're going to see in this class. Again, if you have any questions, let me know.